Hello, and welcome to Super's class on Mario Kart DS game mechanics. Today I'm going to be talking about wall-assisted super bouncing. This technique allows you to gain a lot of height in specific situations and is used for the newest shortcuts in Luigi's Mansion, Delfino Square, and Waluigi Pinball. And Koopa Beach, too. In the first part of this video, I will talk about game mechanics directly related to wall-assisted super bouncing. In the second part, I'll talk about some additional considerations that come up when doing them in practice. The goal of this video is to help you understand how wall-assisted super bounces work and what goes into performing them. To keep things short, I will simplify and leave out details. I'll put an asterisk on screen whenever I fib. Okay, on to wall-assisted super bouncing. Except we first need to understand bouncing. To start, let's look at vertical speed. This is a number that the game uses as part of calculating your kart's movement. Each frame, vertical speed is added to the y component of your movement for that frame. I'll put vertical speed on the screen here so you can watch how it changes. While in the air, vertical speed decreases at a constant rate due to gravity. Upon bouncing, vertical speed becomes positive, so your kart starts moving upward. While on the ground, vertical speed is not set to 0. Instead, it's about negative 0.85, and the floor counteracts this downward movement each frame. This is why you can drive over a slight downward change of slope without any airtime. There are a few conditions that must be met before you are able to bounce at all. For example, jumping normally does not result in a bounce. One of these conditions is that you must either A. have been in the air for at least 26 frames, or B. fallen a total distance of over 30 units relative to the last place you touched a floor. The amount of vertical speed that you get from a bounce depends on how fast you are moving towards the floor. The resulting vertical speed must be above 1.2 or no bounce will happen. There is also an upper limit of 1.5. Strangely, this upper limit is affected by off-road. The limit is multiplied by the same amount as your top speed multiplier for that floor type, even if you are using a mushroom. Alright, now we can move on to super bouncing. Now, you may have heard people talk about super bouncing when talking about the new shortcuts, and they are usually actually referring to wall-assisted super bouncing, but in this video I distinguish between the two because they are different game mechanics. Super bouncing is simply when you bounce and jump at the same time. So, let's look at what jumping does for vertical speed. It adds 2.1. It does not simply set the value to 1.25, it adds. This means that if you have 1.5 from a bounce, jumping will make it 3.6. This gives much more total height than either bouncing or jumping alone. But this is still not nearly as much as you need to get over this invisible wall in Waluigi Pinball. For that, you need to go this high. Oh, sorry, you can't see that? Hang on. For that, you need to go this high. So, onto wall-assisted super bouncing. This is when you use a wall to gain extra height in addition to super bouncing, but unlike hopping and bouncing, this does not rely on vertical speed. To understand wall-assisted super bouncing, we need to know a little more about how karts move. In particular, there are two values we need to look at: horizontal speed and movement vector. Horizontal speed is, like vertical speed, a number that says how many units to move each frame. Unlike vertical speed, movement from driving needs to happen in 3 dimensions, and that's where movement vector comes in. Movement vector is what's known as a unit vector. Basically, it's just a direction in 3D space that says which direction to move. While driving on a floor, movement vector is kept parallel to the surface your kart is on, so you just move along the floor unless vertical speed says otherwise. Since we're looking at how to gain height, only the y component is really relevant here. Notice how when you drive up a slope, the y component is positive and your kart moves upward. When you go into the air, movement vector continues to apply, and so you get the upward movement from that, and then vertical speed is applied. This is why driving off this ramp doesn't immediately make your kart move downward, even though vertical speed is already negative. However, movement vector is not only updated when you touch a floor, it's also updated when you touch a wall. But instead of making it parallel to the wall, this time it is updated based on your kart's orientation. To see how this works, it is helpful to look at another value, target movement vector. Target movement vector can be thought of as the direction your kart is trying to go, and it gets continuously updated in the air based on your kart's orientation. When you touch a wall, the y component of movement vector is just updated to match whatever the y component of target movement vector is at that time. So let's watch the target value while driving off this ramp. Without pressing anything on the D-pad, it of course starts out the same as movement vector, but over time the cart levels out and the y component begins going down. If we angle the cart up or down by pressing down or up on the D-pad, again the y component follows the cart's changing orientation. Importantly, notice that the cart's orientation is a little slow to match whatever vertical angle it's moving towards. This is true for pressing down as well as for landing. This means if you touch the wall immediately after bouncing, you can still have a significant upward trajectory in movement vector despite your cart beginning to align vertically with the floor. I haven't been showing the x and z components of movement vector, but they are also updated when you touch a wall, so turning away from the wall can actually make you move away from the wall, preserving that upward trajectory. Now, all of this would be enough to go over the invisible wall, but not as high as in this video clip. There's one more source of height here, which comes from how jumping affects target movement vector. You can see when you jump that this angles your cart upward a bit and then returns to facing directly forward. This change in orientation affects target movement vector, except this time the impact is immediate. The y component does not gradually follow the orientation of a jump, and it maxes out at 2 frames after jumping. So the highest possible height comes from moving away from the wall 2 frames after jumping, maximizing the vertical angle from the hop. We can now put everything together. Aim your cart slightly towards the wall while driving off this ramp. Press down to angle your cart upward. Jump on the same frame as you land to do a super bounce and be touching the wall at this point. Finally, turn away from the wall to preserve the upward trajectory. So you now have an upward trajectory similar to driving off a steep slope, plus the vertical orientation of jumping, plus the vertical speed of bouncing and jumping. Okay, that's just about everything about how wall-assisted super bounces make you go really high. But in practice, there are more things to consider. As I've mentioned, one condition for bouncing is being in the air for at least 26 frames. And it just so happens that this is also the maximum number of airframes it's possible to get from a regular jump on flat ground using a wall. And since the height from the wall is based on horizontal speed, you need to be close to maximum boost speed for this bounce to work. Touching a wall applies a multiplier to your cart's maximum speed. The multiplier value depends on the angle between target movement vector and the wall, with lower angles giving better speed. So if you touch the wall at a sharp angle before bouncing, your speed will go down by a lot and you may not regain that speed on the 1 frame you're on the ground. Also, the fences on Waluigi Pinball are special. For most walls, the maximum value of this multiplier is 80%, but for these fence walls, the maximum is 100%. And the invisible walls here are regular walls, so if you touch the invisible wall above the red fence, you will lose speed. When using a wall for height on flat ground, it may be necessary to drift in order to line up correctly or mini-turbo. Since drifting makes your cart move somewhat sideways, there is necessarily a significant angle between movement direction and the wall, giving a low wall speed. This bridge on Delfino Square is just barely long enough for me to regain enough speed before jumping. If you touch a wall while facing away from the wall, you will lose a lot of speed and your cart will spin. This can be a problem because when the X and Z components get updated, they aren't set to match target movement vector. They change by some percentage of the difference. This is how slippery roads work. They lower that percentage. So if your angle changes to face just slightly away from the wall, your actual direction of movement may still be slightly towards the wall, and you will hit it while facing away from it. The cart's angle is represented by a 16-bit integer value. However, some trigonometry operations are done using a lookup table with only 2048 entries. So your angle is rounded down to the nearest multiple of 32 first, making it impossible for target movement vector to point in certain very specific directions. Now, the actual movement vector doesn't necessarily match the target value exactly, but it is usually pretty close, and this causes problems when trying to move away from the wall while still staying very close to it. Due to a misaligned rotation axis, the cart's up-down orientation can slightly affect X and Z movement components. For shortcuts where you need to move along the wall after a regular bounce and before the super bounce, this can cause parallel movement to become unparallel, sometimes resulting in seemingly random bad wall hits, or moving away from the wall slightly. But this can also be useful. Remember, angle has limited precision, so this small change from pointing the card upward can be used to get more precise angles. Because movement vector is a unit vector, a larger y component means smaller horizontal components, so it may be best to get less height than the maximum possible to keep more horizontal speed pointed forward instead of up. And last, the jump button is also the drift button. So if you press jump on the frame you land from another jump, you will drift, making it impossible to jump directly into a super bounce. That's why a regular bounce is needed here on Delfino Square. And now you know how wall-assisted super bounces are done. Thanks for watching.